Well, this is my first attempt at a high-powered soldering iron, and with many first attempts it was a initial failure. I'll tell you a little bit about it before I modify it. So basically what I took was a standard copper soldering tip. Probably recognize those from kind of a handheld Weller, or mine was a Craftsman soldering iron. I think the size that these fit are like 100 to 140 watt handheld soldering gun. But for one of my projects, let me show you. This is a boost pack using 350 farad ultra-capacitors, and it's got real heavy copper in this PCB. I'm connecting them all in series, and you can see right there I took a stab at, if my camera will focus here, took a stab at soldering it. Camera doesn't want to focus. Anyways, it's ugly looking solder joint right there. Didn't get it hot enough. I took a stab at soldering it with a couple different means. First, the 140 watt handheld soldering gun, and that didn't get hot enough. You could get the solder to melt a little bit, but there's too much heat sink in all of this copper, and probably the cap as well, that you can't get enough heat to it with around 100 watts of power. So I also tried this big piece of copper cable. I kind of cut it up to a point and heated it up until one of those strands was glowing hot red, and then tried that, and that gets hot enough and enough heat transfer to melt, but it's just too short-lived. It cools down too quick, obviously, because the whole rest of this is a heat sink pulling the heat away to the end. So what I wanted was a steady, high-powered heat source, and I can't blow a torch straight on this, otherwise we'll melt this, whatever that stuff's made out of, with a PCB. So I had a brilliant idea to build a high-powered solder iron, and I've been using these not SD, whatever these connectors are called. You can get this is a female one, but that's what the male end looks like. And I built these male ends. It took me a full day to do this, and so I got to play around a little bit on my lathe and a little bit on my mill. I cut grooves in the ends of these so they kind of sit in there. And this camera is not doing very well. Anyways, I cut little keyways in there, milled little keyways in there, and then just use a hose clamp on. Obviously this is loose. I was going to use some wood to clamp these together and insulate them at the same time. So this part worked out fine. I got these kind of cam lock connectors to fit. These are high amperage, they're for welding cable. And 1/2 inch aluminum round tube is what it's built out of, which I picked because it's, big enough to hold high current, and it's the same size. It's slightly smaller than that diameter, but it's close enough to work. And I just used brass, I think it's 3/16 rod to go through there. Just drilled a hole through these, put it through, and then soldered it. I learned that like your electrical solder for wiring does not stick to aluminum whatsoever. Even if you put flux on it, it does not stick. So if you're ever joining brass to aluminum, there's this I'll go show you. There is, where is it? This, got this a while back at Home Depot. Pretty expensive stuff. It came with 2 rods, and it was probably, I don't know, close to $10, I'd imagine. But it's brazing and welding. Wow, this camera. These iPhones are supposed to have better cameras. Anyways, benzomatic, brazing and welding. There you go. It's a little bit better. Aluminum. Okay, aluminum brazing rods. It doesn't give you a tensile strength, but it gives you a Brunel hardness 100 and working temperature 700 to 750. So you can use your typical torches. It's plenty hot enough, and it doesn't melt the base aluminum. So that was the first time I used that, and I'm happy I got to experiment with it with this project. Works good. It fused to the aluminum and to the brass, so that'll hold them in there good. If you ever want to build these style connectors, dints, that's what they're called, dints connectors. So if you ever want to build your own male dints connectors out of aluminum, get that aluminum brazing stuff. Obviously I welded all this together. This is just, I think, 1/4 inch plate that I was able to break in my cool 3-in-1 slip roll brake.